look at your homework here. Question number 7 on your homework. Question number 7. Again, those first 6, I believe, are just molar mass, the things that you did last night for homework, so I'm not going to work any of those out. You're pretty good at those. Just more practice for you. So here, and again, try to remember your sequence. So kilogram, gram, mole, molecule, and or molecules, whatever, atoms. Okay. And then it can go in the reverse direction. But again, remember, it's a one-way street. Now, sometimes we can bypass molecule and go straight to atom if you do not have a compound. If you have a compound, you got to go through molecules before you can get to atoms. Okay. All right. So let's do this first one. So again, 58.7 grams. What are we given? Grams. So we're starting here, right? And the question wants to know number of moles. So how many steps? 1. Are you going to use Avogadro's number in this problem? No, that's what we did yesterday. So pretty bad example I just gave. So start with what you know, 58.7. Don't worry, there's more. And we're going to look for 1 mole, or what the molar mass for copper oxide is. Copper has a molar mass, yep, 63.55. Good. Oop, go back. So 63.55, and oxygen 16. So my molar mass, and again, you don't have to do this. I just do it to make sure everybody's on the same page. So 58.7 divided by answer. So 0.73, 737, 738. Okay. So just like what we did last night. So no big issue there, I hope. Okay, let's take a look at number 12. Now it's starting to get into some fun. Okay. So here, number 12 says 12.03 kilograms of sulfuric acid, H2SO4, and it wants to know how many molecules. So in this problem, we're starting with kilograms, and we're going to what? Molecules. So we're going to go here. Okay. So starting with kilograms, going to molecules, so you're going to have a 1, 2, 3 step process. And that's probably a good way to do that. Just have this written on top, and then realize, okay, I'm starting here, I need to go there, so I need to convert the kilograms to grams, grams to moles, moles to molecules, and I'm done. So, start with what you know. So I have my 12.03 kilograms, and again, kilograms is not what I want, so move it diagonally. And what am I converting that to? Grams. And which one's bigger, kilogram or gram? Kilogram, very good. How many grams in a kilogram? 10 to the third. Okay. Again, retrieving the information from the past, we love it. Oop, come back. Okay, so again, what's the next step? Go to mole, very good. So if it's not what we're looking for, we're going to move gram here, and 1 mole on top. And it's sulfuric acid, H2SO4. Actually, I'm going to erase that gram unit. So looking at hydrogen, we have 2 of those, 1.008 from the periodic table. And sulfur is 32.06, good. And how many oxygens? 4 of those. Okay. Okay. And we have one more step, right? So we need to convert the moles to molecules. So if it's not the unit you're looking for, move the unit diagonally. And notice, 1 mole 1 mole. Okay, so whenever you have mole within the problem, until otherwise stated, leave it as 1. So how many molecules are in 1 mole? Very good. 6.02 times 10 to the 23. I'm just going to call that molk. If you want to abbreviate molecule, you can put molk. How's that? Unless you want to write out molecule. That's your call. Now, here's something I want you to recognize. Look at the units. Kilogram, gram, mole, molecule. So whichever direction you're going should be kilogram, gram, mole, molecule on top. If we're going in the opposite direction, then these units will be on top, going in the opposite direction. That's one real quick way to make sure that you're doing the right process here. Okay. Now, let's see if you can type all that in. Here's how, if you're going to do it all in one fell swoop using parentheses, 12.03 times 1 EE3 times 6.02 EE23 divided, open up that parenthesis. There's our first parenthesis. And then all of that, 2 times 1.008 plus 32.06 plus 4 times 16. Close that parenthesis, hit your equal sign. That'll give you the correct answer. Okay. So order of operation takes care of this, and then once we hit that divided button there, now we have to tell the calculator we're going to do some multiplication down here, but we want to take care of that first. Okay. Anybody get a number there? 7.38 times 10 to the 25th? And what's my unit there? Molecule. Okay. Very good. So in 12.03 kilograms of sulfuric acid, there are 7.3 times 10 to the 25 molecules. More than I could ever count, or would want to count. Okay. Want to do one more? Sure, it's my homework. Let's look at number 15. Okay. And we're going from grams to atoms this time. So our sequence, so we have, so now we're starting here and we're going here. Okay. Can I bypass molecule? No, because I have a molecule, so I don't want to do that. That would only take place if I gave you a single type of element, which I'm not doing yet. All right, so here we go. Start off with what you know. So 79.54 grams. Actually, try this on your own. Try this one on your own. Don't peek up here. Okay, see how you guys are doing here. And TA is right next to tungsten, below vanadium. Not one of your 52s, so don't freak out about that. Now the last step is interesting. In one molecule of Ta2O5, how many atoms are there? How many? In one molecule of Ta2O5, how many atoms are there? 7. 2 plus 5 is 7. Okay. So here's when we look at our, remember our verticals? These things are equal to each other. Okay. So in one molecule, I have 7 atoms. In 1 mole, I have 6.02 times 10 to the 23 molecules. In 6.02 times 10 to the 23 molecules, I have 1 mole of something. And in 1 mole of Ta2O5, whoop, that's a bad 5. I have this molar mass, whatever it is. Okay. So keep the columns equivalent. Okay. And let's see what we did here. Times 10 to the, was that 23? multiply on the top. Here's how I type this one in. Actually, I didn't use parentheses until the bottom, so 79.54 times 6.02 EE 23. Still no parentheses because order of operation is keeping that intact. Times 7. When I hit that divided button, then I open up the parentheses. Then I just type all that in, close the parentheses. Now, and I realize that I write with parentheses here. I apologize for doing that, but I'm trying to show a break in the action, so to speak. In other words, that these two are together and these two are together, divided or separated by a plus sign. Don't necessarily type it in as I write it. That's just one way that I help to separate what's going on there. Yeah.
Do you have to open up with parentheses? Like, I typed it in where I just typed it in exactly how it is, like how you did it, except without those parentheses that you just put after the division sign, and I got the right answer.
With this problem?
Not necessarily that problem.
Yeah. I would be careful because if you have something like this with multiple values, if you did this times this and that was that, as soon as you hit that plus sign, it's going to take whatever's on top, multiply it out, divided by that, and then it's going to add this top part right up here. It's going to put it right here in the equation. So that's what the parentheses do. It helps to keep it in the correct spot, which is down here. Ooh, that was interesting. Okay, so just be careful on that. Wow. Any other questions? Right, good? All right, so work on that worksheet.